Hey, what's up, chem peeps? More multiple choice. Consider the following reaction. Boom. With concentrations of boom at equilibrium for a given temperature. If the same reaction was completed using different concentrations, boom, what would happen? First, let's write equilibrium constant expression for this equation. K is going to be equal to concentration of SO3 squared over concentration of SO2 squared times the concentration of O2. Again, these exponents are coming from the coefficients in the balanced chemical equation. Plug these numbers in. 0.7 squared over 0.2 squared times 0.5. All right, let's simplify. Let's keep solving. 0.7 times 0.7 is going to be 0.49 over 0.2 times 0.2. That's going to equal 0.04 times 0.5. Okay, now I encourage you to use scientific notation if this is confusing for you. This is really 4 times 10 to the minus 2. And this is really 5 times 10 to the minus 1. Now just multiply your coefficients. 4 times 5 is 20 times 10, add your exponents to the minus 3. So we've got 0.49 over 2 times 10 over 20 times 10 to the minus 3. All right, let's keep simplifying. This is really about 0.5. And to put this in the correct scientific notation, it's going to be 2 times 10 to the minus 2. And this is really 5 times 10 to the minus 1. Now, in my opinion, it becomes a lot easier. 5 divided by 2 is 2.5 times 10. And again, when we're dividing, we subtract our exponents. So -1 minus -2. So our value of K is 2.5 times 10 to the 1, or 25. Okay. Now, that same reaction completed using different concentrations. We don't have equilibrium concentrations, or we don't know. We're just given these different concentrations. Q is going to be defined the exact same way as K. Concentration of your products over the concentration of your reactants. So let's just plug those numbers in. All right, now let's simplify. In our numerator, we're going to have 0.25. In our denominator, we're going to have 0.01 times 0.3. Keep going, it's going to be 0.25 over 0.003. Now, I'm going to make a little bit of an estimate here. This is pretty close to 0.3, or 3 times 10 to the minus 1. In the denominator, we have 3 times 10 to the minus 3. 3 divided by 3 is 1 times 10. Again, we're going to subtract -1 minus -3, or 2. 1 times 10 to the 2 is about 100. So now we're going to compare K and Q. Do it alphabetically. Q is larger than K. So use the little arrow to help you decide which direction the reaction will shift. It's pointing to the left. It's going to shift back to the left to establish equilibrium. So K is less than Q, the reaction will shift left. Answer choice B. Done.